everybody, let's continue our lesson curved mirrors. First of all, we identify what's the meaning of curved mirrors. Mirrors with curved reflecting surface, it's known as curved mirrors. Mirrors with curved reflecting surface known as curved mirrors. Then this reflecting surface, we consider it's a part of a sphere. Therefore, we can give another name for curved mirrors, that is a spherical mirrors. Okay, now then identify the two types of curved mirrors. There are main two types of curved mirrors. These are the concave mirrors and convex mirrors. Then identify what is the difference between concave and convex mirror. Concave mirror means the reflecting surface. Then you look at this diagram. Reflecting surface of this concave mirror, reflecting surface of this mirror curved inward. That is known as concave mirror. Then convex mirror means the reflecting surface of this mirror curved outward. The reflecting surface of this mirror curved outward, it is the convex mirror. Then you know about the difference between concave and convex mirror. According to these two types, then we identify there are some terms related to these two types of mirrors. Now we learn this. We can get this reflecting part of the mirror. It's a reflecting surface of this mirrors. It's a part of a sphere. According to that, we identify then in the first figure, first diagram, this is the concave mirror. This is the concave mirror. This reflecting surface curved inward. Then this is the sphere. This is the sphere. We can imagine there's a sphere that these reflecting surface belongs. Then according to that, we identify so many terms. These terms are very important to each of these convex and concave mirror. These terms are the center of curvature, pole, and the principal axis. Then what are these three things? The center of curvature, pole, and the principal axis. Then first I explained according to the concave mirror. This is the concave mirror. This is the concave surface. Then we consider about this sphere that this surface belongs. The center of that sphere, this one, the center of the sphere that this reflecting surface belongs, that is known as the center of curvature. Symbolized as C, center of curvature. Then this is the pole. Pole means the center point, midpoint. The center point of this concave surface, that is the pole of the concave mirror. The symbolized as P. Then other one, the line joining this P and C. The line joining P and C. This is line known as principal axis. This is known as principal axis. Then it's same to the convex mirrors also. This convex mirror, its reflecting surface curved outward. Then this is the sphere belongs this reflecting surface. The center of this sphere known as the center of curvature of this convex mirror. Then this is the pole, that means center point of this convex mirror, that's the pole. Then line joining the C and P, that is the principal axis of this. That is the principal axis of this convex mirror. Then always this principal axis is perpendicular to this mirror surface, especially at P. In the convex mirror also, this principal axis always perpendicular to this mirror surface, especially at P. These are the terms to identify. These terms are very important to draw the ray diagrams. This is later part of the lesson. We draw the ray diagrams according to the convex and concave mirrors. Then these terms are very important. Then we are going to the next part. focal point of a curved mirror. Focal point of a curved mirror. Focal point we known as focus of the curved mirror. Then according to this convex and concave mirror, we identify how where's the position that focal point focus is formed. Then we describe that first we get the according to the concave mirror. This is a concave mirror, figure 5.8. This is a concave mirror. Then how this focal point is formed? We get the a ray. We get a ray. It's coming towards the mirror, parallel to the principal axis. It's coming parallel to the principal axis. The incident, the mirror. Then after that, it's reflection. These rays goes through some kind of a certain point of this principal axis. Then we get the another ray. It's coming parallel to the principal axis. Then after the reflection, it goes through also some point of this principal axis. Then we get the intersect point of these two rays. This intersect point. That point we known as the focal point of this concave mirror. Focal point of the concave mirror. Then especially when we are drawing this diagram, we need to know about the convergent and divergent beams. You learned earlier this especially convergent parallel beam. Remember, convergent means the light rays, many light rays meet at one point. Therefore, in this concave mirrors, these light rays, they are reflected as a converging light beam. This one, these light rays, after the reflection, these light rays meet at one point as a converging light beam. Therefore, according to the concave mirror, these are the converging light beam. Then that focus point, that point known as the focal point or the focus of this concave mirror. Then I describe according to the convex mirror. This is the convex mirror. This is the convex mirror. Then this is the pole of the mirror. Then we get the rays. This also coming towards the mirror, parallel to the principal axis. Then then incident the mirror. Then after the reflection, it travels back this way. When extended this is the point. It's come through the principal axis. We get the another parallel ray. This one. This intersect point. That's point the focal point. Focal point of this convex mirror. Focus of this convex mirror. Then these rays, these rays come in as the divergent light beam. Divergent means light rays travel away. Light rays travel away a certain point. This one. Light rays travel away a certain point. Therefore, this is the kind of divergent parallel beam. Then especially we given here F and C. F means focal point. Then what is the C? C means center of the curvature. Then this diagram given P, the distance between P to F. P and F, it's equal to the distance between F and S. C. The distance between P and F equal to distance between F and C. Then what's the meaning of that? Always in this also same to all these two types. In the always F focal point, it's a midpoint between P and C. The line joining pole and center of curvature, the midpoint is a focal point. Therefore, we know as then also we identify the focal length and the radius of the curvature. Focal length means the distance between pole to the focal point. That's a focal length. We given as simple F. This is the focal length. We given as simple F. Then the distance between C to P, center of curvature to pole, that is the radius of the curvature. That is the radius of the curvature. Then always this radius